There is an uncomfortable possibility being discussed more and more seriously by modern science. What if time doesn't exist? At least not in the way we imagine it. Because while physicists are starting to try to understand parallel universes, quantum computers are slowly starting to come out of the laboratories. And artificial intelligences are already creating materials that might allow us to build small artificial suns right here on Earth. At the same time, artificial neurons are starting to communicate with living brains, and humanoid robots, my friends, are taking another step into human life. Maybe reality, astonishing as it already is about to become much stranger than science fiction has shown us in recent years. Let's break all this down and look at a few other new technologies too. Hello everyone, I'm Carlos Salvez. It's freezing cold here, and you're watching Realidade Impressionante. What if I told you that maybe the present doesn't exist? In some areas of modern physics, the past, present, and future may be happening simultaneously in a kind of eternal block. Albert Einstein already said that the distinction between past, present, and future is just a stubbornly persistent illusion. But in 2026, this discussion stopped being just philosophical. Between Google's quantum chips, time crystals, and scientists trying to send information to the past, science is slowly, very slowly, okay, starting to admit something uncomfortable. Maybe time isn't exactly what we imagine. Maybe it's a construct of the mind and we're learning how to manipulate it. But then an inevitable question arises. Why do we perceive time in a linear way, as if it were a straight line? Scientists like Robert Lanza, through the theory of biocentrism, argue that time is not something that happens out there in the universe, but rather a process directly linked to consciousness. Without the observer, the universe would exist only as a gigantic soup of probabilities, where everything happens at the same time. And if this is true, then the feeling of past and future might just be a biological interface created by the human mind to be able to organize reality. And this is where things start to cross the border between philosophy and technology. One of the most curious experiments comes from Google Quantum AI, which recently drew attention again by studying the so-called time crystals. The idea seems absurd at first glance. Unlike ordinary matter, these crystals can oscillate continuously without consuming energy in the traditional way. In other words, they break something that physics has always treated as almost sacred: time symmetry. And this didn't just stay in theory, okay? In 2026, researchers like Daryl Seligman and teams of physicists in Brusque presented simulations involving two temporal dimensions coexisting simultaneously. The goal of these guys, at least that's what they say, right? It's not to create a cinematic time machine, at least not for now. The real bet is on quantum computing. The hypothesis is that future processors might be able to exploit phenomena involving retrocausality, performing certain calculations in such an unusual way that, in theory, the result would seem to influence the system's own computational past. Yeah, I know. It sounds like science fiction. But some areas of quantum physics are already seriously working with these mathematical possibilities, okay? And while Google explores time at the microscopic level, another scientist is trying to tackle the problem on a much larger scale. Physicist Ronald Millett from the University of Connecticut has spent decades working on a possible time machine, directly based on the equations of Einstein's theory of relativity. The guy's experiment involves lasers circulating in a ring to try to bend space-time using light itself. The logic is relatively simple, although the consequences are absurd. According to Millett's calculations, if you can deform space intensely enough, you can also deform the flow of time, creating a kind of loop. And the most curious thing is that Millett isn't necessarily talking about sending people to the past. The first theoretical application would be much more modest and still revolutionary, okay? Transmitting information to the past up to the moment when the time machine is activated. And if something like this, man, really works, the very idea of memory, causality, and history will need to be rewritten. And maybe all of this connects with one of the strangest interpretations in modern physics, the so-called block universe. According to this view, every moment of our lives already exists simultaneously within a fixed four-dimensional structure. The past hasn't disappeared. The future hasn't been created yet. Everything is simply already there. That's just a manner of speaking, right? Scientists like Max Tegmark from MIT suggest that human consciousness works like a flashlight beam passing through this block. We only illuminate one point at a time, creating the sensation of temporal movement. And if this interpretation is correct, time travel might not be about building machines capable of moving the body between eras. Maybe it's about altering perception, consciousness, or informational access within a structure where all moments permanently coexist. The future, in this case, wouldn't be coming. It would already exist. And in the end, my friends, maybe science is slowly discovering that time is not the script of reality, but just the stage where consciousness interprets existence. And you, what do you think about all this? Can you imagine a universe where yesterday and tomorrow are just different places within the same eternal structure? Maybe the most important question isn't whether time exists, but whether we are the ones who learn to see it that way. And speaking of all this, be aware that right now, quantum computing is just beginning to leave experimental labs and enter the real world. Quite a coincidence, huh? And what if every decision in your life created a new version of yourself in another universe? Not as a metaphor, okay? It's not crazy either, but rather a real consequence of quantum physics. Yeah, I know that sounds like a science fiction plot like we mentioned in the other article, but that's exactly the idea supported by the Oxford physicist Vlatko Vedral. According to him, the popular interpretation of the so-called observer effect might be completely wrong. And maybe human consciousness doesn't have any special power over reality. For decades, many people have interpreted quantum mechanics like this. Particles exist in multiple states at the same time until someone observes them. At that moment, so-called reality would choose a single outcome. That's when several ideas emerged, some almost mystical, about consciousness creating the universe. But Vlatko Vedral argues that physics doesn't exactly point in that direction. According to him, quantum collapse doesn't happen because a conscious mind observed something. It happens because there was a physical interaction. According to him, any interaction. And a simple example he gave helps to understand this. Imagine a photon hitting your glasses. This photon can either pass through the lens or reflect off it depending on various quantum conditions. But it doesn't just hang in the balance, waiting for you to notice the result before deciding what to do. The interaction has already happened even before your consciousness comes into play. But then comes the really strange part of all this. According to Vlatko, the you in quotes who received that photon is not exactly the same you who didn't receive it. On some quantum level, these probabilities would continue to exist simultaneously in different branches of reality. And when you expand that to all the microscopic interactions that happen every second, the idea becomes almost impossible to imagine. But let's try. Let's go. Each choice, each movement, each particle interacting with another could constantly generate small branches, not necessarily creating completely different cinematic universes, but slightly different versions of reality that would be emerging all the time. It's as if existence were constantly branching into infinite parallel possibilities. Yes, basically what he says is, versions of you and me could be existing in parallel universes and could influence our reality here in this world. And maybe the most uncomfortable thing about all this is realizing that in this interpretation, you wouldn't exactly be the center of reality. You would be just one of countless possible versions going through a specific sequence of quantum events. Vedral compares this, in a way, to the famous Schrödinger's cat experiment. As long as there isn't enough interaction to redefine the state, multiple possibilities coexist at the same time. The difference is that in this case, the cat would also be you. And this inevitably raises a strange question about our identity. If there are countless versions of ourselves emerging at every moment in different branches of reality, which one is me and you, the real one? Maybe none, or maybe all of them are, because the more quantum physics evolves, the more it starts to raise uncomfortable questions about the very nature of reality. Crazy stuff, isn't it? China has just unveiled a quantum computer called Huanoid 2. It has 200 qubits, a dual-core architecture, and according to Chinese researchers, it consumes less than $7 kilodolars of power. And this might seem like just a technical detail until you realize what's usually needed to keep a quantum computer running. Most current quantum systems depend on extremely cold environments, using complex cryogenic cooling structures that consume huge amounts of energy. This happens because many qubits are extremely unstable and easily lose their quantum properties when interacting with the environment. Huanoid 2 tries to solve this problem by taking a different approach. Instead of using trapped ions or superconducting circuits like many traditional quantum computers, it was built using neutral atom technology. And that changed things quite a bit. Since these atoms don't have an electric charge, the system becomes more energy efficient and requires much more external cooling infrastructure. According to the developers, the machine can operate using only a relatively compact laser cooling system. The most interesting part is likely the dual-core architecture. In practice, Huanoid 2 works like two interconnected quantum processors operating simultaneously. The two cores are able to split computational tasks between themselves and even help with error detection and correction during processing. It may seem simple compared to the world of traditional computers, but in quantum computing, this represents a huge challenge. Because one of the biggest problems in the field today is not just increasing the number of qubits, it's being able to maintain stability and reliability while these qubits interact with each other. And this is exactly where the entire industry faces difficulties. Researchers all over the world are still very far from being able to control millions of qubits in a stable way. And that's why many companies are starting to abandon it, at least temporarily, right? The idea of cool machines and start focusing on smaller systems, but ones that are more usable in our real world. The Huanoid 2 seems to follow exactly this philosophy. Instead of chasing absurd numbers of qubits, the Chinese researchers decided to prioritize stability, energy efficiency, and much more practical industrial applications. According to Chinese state media, important indicators related to the reliability and lifespan of the qubits have already reached levels considered world-class. For a long time, quantum computing was sold almost as a distant futuristic promise. But now, some countries at least are slowly starting to turn these systems into real technological infrastructure. And maybe the strangest part of all this is realizing that while we try to understand reality, we've also already started, though still slowly, to recreate the human brain itself in the lab. Let's see. This is really interesting. Modern technology has always tried to imitate the human brain, using machines that, deep down, still work in a completely different way from it. Traditional computers rely on billions of rigid transistors, organized in an extremely precise way and consuming increasing amounts of energy to handle increasingly complex artificial intelligence. But the human brain operates differently. It is flexible, three-dimensional, adaptable, and made up of neurons that constantly change their connections and patterns of activity. And that's exactly why scientists all over the world have been trying to create a new generation of hardware that's directly inspired by biology. Researchers at Northwestern University have made a significant step in that direction. The team developed flexible artificial neurons that are not only capable of mimicking brain signals, but also of directly interacting with living neurons. Until now, many so-called neuromorphic systems only simulated neural behavior mathematically. What these researchers have done now is create physical devices that are capable of producing electrical impulses that are extremely similar to the real signals used by the human brain. And the test became even more impressive when the scientists connected these artificial neurons to the living brain tissue of mice. Artificially generated signals activated real neural circuits. In practice, biological cells responded to the impulses created by the machine. What's most interesting is how all of this was built. Instead of using traditional rigid silicon chips, the researchers developed electronic inks made from materials like graphene and molybdenum disulfide. Using aerosol printing, they deposited these materials onto flexible surfaces to create devices much closer to the organic architecture of the brain. And the result was something quite unusual. Artificial neurons capable of producing different firing patterns, bursts, and continuous signals similar to those observed in real biological systems. And this not only brings electronics in the brain closer together, but it can also change the very way we think about computing. Because today, artificial intelligence faces a growing problem of energy consumption. The more data the models process, the greater the need for energy, servers, and massive computational infrastructure becomes. The human brain, on the other hand, runs on about as much power as a very dim light bulb. So there really is a silent race to create computational systems that are more similar to real biological neural networks, which would be able to learn and process information much more efficiently. But artificial intelligence alone no longer seems to be enough. The challenge now is to bring machines into our physical world in a natural way using artificial intelligence. Figura AI recently presented its new demonstration of the Helix 002 system. For the first time, two Figure 03 humanoids were shown reorganizing autonomously and in a coordinated way an entire room, according to the company. And the most impressive part? It's not the tidying up itself, but the way it happens. Normally, systems with multiple robots rely on some kind of centralized controller telling each machine exactly what it should do. The server distributes tasks, synchronizes movements, and avoids conflicts. But Figura claims that here, there isn't a so-called boss controlling everything. Each robot operates as an independent agent. They observe each other using their own cameras and infer their partner's intentions, almost in real time, like what two humans do when one acts as the boss. What's possible is, and that really changes things, Because the Helix 02 system was created precisely to replace thousands of lines of manual programming with a unified model of vision, language, and action. Instead of relying on fixed rules for every possible situation, the robots now learn to react directly to the environment. In practice, they start, even if slowly, to develop something close to adaptive behavior. And the demonstration really makes that clear, In one of the most curious moments, one of the robots shifts its body weight onto a single leg while using the other to press the pedal of a trash can. It seems like a simple detail, right? Yeah, until you realize the level of balance, body control, and dynamic adaptation that's needed to make that happen. The robots also open doors using full body coordination, rearrange objects in the air, and deal with some of the biggest nightmares of modern robotics: fabrics. Making a bed might seem trivial to some of us humans. Some people don't even do it, I know that, But for a machine, a comforter is pretty much pure physical chaos. The fabric constantly changes shape. It folds, slides, and creates unpredictable patterns in real time. So, robots have to constantly recalculate tension, position, and movement. All of this while they're manipulating the material together. And maybe that's exactly where the demonstration becomes really important. Because for several years, the robotics industry has mainly focused on industrial environments that are highly controlled. Organized factories, standardized objects, and repetitive tasks. But an ordinary house is completely different. It's unpredictable, it's disorganized in many cases, and it's full of little ambiguous situations that humans solve without even thinking. And teaching machines to survive in this domestic chaos may be one of the greatest challenges of physical AI. Figure already openly talks about turning these humanoid robots into household products rented monthly, almost like a car subscription. The idea would be to offer continuous assistance inside the home 24 hours a day. But even Brett Adcock, the company's CEO, admits that he still supervises these robots near his own children while the technology is evolving. And that says a lot about the current moment in robotics. Because for the first time, the challenge no longer seems to be making the robot move. It's about making machines coexist naturally within human spaces without seeming completely artificial. And behind these increasingly natural humanoids, right? There's engineering that may still be in its early stages, I know, but is already starting to imitate even human anatomy. Let's take a look at a bit of that. There's a huge difference between seeing a robot walking in a demonstration and really understanding what's behind that machine. Recently, Foundation Robotics released the most detailed videos ever made about the Phantom MK1, their latest generation humanoid robot. And at first glance, everything looks extremely futuristic. Sophisticated robots, hands inspired by human anatomy, and an almost cinematic narrative about the future of automation. But when you start looking behind the scenes, you notice something much more interesting happening there. In one of the videos, CEO Sanket Pathak gives a tour of the so-called RoboFactor 1. This is the company's San Francisco headquarters. And the most curious detail is that despite the futuristic look, most of the robot construction still happens manually. The Phantom MK1 has about 500 unique parts. Technicians are shown assembling gears by hand, fitting mechanical components piece by piece, and soldering electronic parts almost like a high-tech craft workshop. And maybe this reveals a little discussed reality behind the humanoid robot race. Because behind these impressive social media demonstrations, many of these companies are still in an almost experimental phase of manufacturing. The future looks extremely advanced on camera, but behind the scenes, there's still a lot of human work supporting all of this. Even so, the Phantom Mk1 stands out because of some very important technical details. The structure of the legs, for example, uses titanium rods developed to withstand the constant vibrations of bipedal locomotion. The head integrates 6 different cameras to provide a field of view close to 360 degrees. And the mechanical heart of this system lies in something called cycloidal actuators. These actuators offer much greater energy efficiency than traditional systems, and also allow for something extremely important: physical sensitivity. In other words, my friends, this robot can quote-unquote feel extreme forces much more precisely, making movement and interactions more natural and safer according to the company. But the most fascinating part, at least in my opinion, is in the hands. The project uses artificial tendons directly inspired by human musculature. Instead of putting motors inside the fingers, the actuators are placed in the forearm, pulling the internal tendons, just as it does in the human body. Foundation Robotics says it plans to produce thousands of these robots as early as 2026. But maybe the biggest technological transformation of our era isn't just about robots, but about the attempt to build a civilization capable of mastering new forms of energy. And that's a really important one. Let's take a look. There's one major obstacle preventing nuclear fusion energy from becoming a large-scale reality. And interestingly, it's not exactly in the physics of fusion, but in the materials. Because creating a small artificial sun inside a reactor means exposing metals to absurd temperatures, as well as extreme radiation and continuous stress for years. But now, scientists at the Ames National Laboratory in the United States believe they have found a new way to drastically accelerate this search. And it involves, of course, artificial intelligence. The team developed a tool called DuckDuckGPT, an artificial intelligence specifically designed to discover new metal alloys for nuclear fusion reactors. And according to the researchers, the system can reduce a process that would normally take months to just a few hours. The researchers simply describe in plain language the type of material they want. Something like, for example, I want an alloy that is resistant to high temperatures with good ductility and suitable for fusion reactors. Artificial intelligence, in just a few seconds, analyzes thousands of possible combinations of chemical elements. And this could end up changing much more than just nuclear fusion. Because the moment artificial intelligence starts discovering new materials practically on its own, it stops just analyzing human knowledge and now begins to directly participate in the technological construction of our civilization. So, if you enjoyed this episode, go ahead and leave a like and check if you're subscribed, okay? Sometimes the platform might unsubscribe you for some reason. Thanks for staying with me. Click one of the 2 suggestions on your screen and I'll see you next time. Just click, okay? Thanks. See you soon. I'll wait for you there. Click now.